Hi guys. Okay, so in our proofs today, we're going to go one step beyond CPCTC, and in my second proof, we're going to look at the HL postulate. Now, when you go beyond CPCTC, you can kind of know ahead of time that you're going to do this if you look at your proof statement. And you can see that it's not asking to prove that triangle's congruent. So it's not going to be a proof that ends with SAS or SSS or anything like that. You can also see that it's not asking for anything else congruent, like it's not asking for sides to be congruent or angles to be congruent. So that's how we know that it won't end with CPCTC, because if it was asking you to prove sides congruent or angles congruent, then CPCTC would most likely be your last step. And then I'll just mark this. It's not asking for triangles congruent, so it won't end with anything like SAS, SSS, etc. That still might be in the problem. In fact, it will be in the problem, and so will CPCTC, but it won't be our final step. So what we're going to do first is list our givens. Angle CFD is congruent to angle EFD, given. And number 2, FD is an altitude, given. All right, so let's think about what these givens are showing us. Angle CFD is right here, and angle EFD is here. So those are congruent. Now, FD is an altitude. That means that FD makes a right angle down here with CE on both sides, like that. So what we could say, since that's leading us in another direction, we could say that angle CDF and angle EDF are right angles. And the reason we know that is because of the altitude. So for our reason, we could just say definition of altitude. Or if your teacher requires you to write out the definition, that's what you would write instead in the reason column. Now, since those angles are both right angles, we know that they're congruent to each other, so we have to say that. So we're going to say angle CDF is congruent to angle EDF. And the reason they're congruent is because they're right angles, so you literally just write that. All right angles are congruent. So that's our reason. So, and then let's just put a little mark. So we know those are congruent. We know these are congruent because that was given. So now we have two angles, which tells me that I'm probably going to use ASA. And that is what we're going to use because we could say that this side is congruent to itself by reflexive property. So DF is congruent to DF. Number 5, that's by reflexive. So now we have enough to say that the two triangles are congruent, which is not our last step, but it still has to be one of our steps. So triangle CDF is congruent to triangle EDF, and that is by ASA. And if you need to list the steps, one of the angles was given to us, so that was 1. In step 4, or let's do step 5, was where we said the sides were congruent, and step 4 was where the other pair of angles was congruent. So 1, 5, 4. And then after you get triangles congruent, most likely in your proofs, the next reason will be CPCTC. So let's just fill that in already. And let's look over here. If we want to prove that FD is a median, that would be a median if this CD was congruent to that segment DE. And we do have CD congruent to DE right now because they are corresponding parts of congruent triangles. So those are congruent by CPCTC, and that's exactly what we needed to be able to say the proof statement that FD is a median. So we can go ahead and state that, and in our reason, it's really just definition of median. So I think most teachers would be okay with writing that. So definition of median. But the definition of a median is that it's a segment that it starts at one vertex, and then where it meets the opposite side, it's bisecting the opposite side. And so that would be our final step. And then let's flip to the next proof. This one, well, I know ahead of time that it's going to be HL. That probably wouldn't be as obvious to you guys until you get farther into the proof, but that's fine. So we are going to first list our givens. So we have circle O. Anytime they give you that you have a circle, it's most likely to let you say that radii are congruent. So we'll look for that in a second. But let's list our other givens. YO is perpendicular to YX, given. And ZO is perpendicular to ZX, is also given to us. All right. And we're trying to prove that YX is congruent to ZX. So let's just keep our mind focused on that, YX and ZX, those two sides. Well, you know in most of your proofs you use triangles. So let's very first draw an extra line into this figure connecting OX, and that's our what they call auxiliary line. So let's just say draw OX. And most teachers have you just write 2 points, determine a line. So we have OX in there, which will help us with the rest of our figure. So step 5, well, they gave us that we had a circle, so why don't we say OY is congruent to OX, because those are both a radius of the circle, and all radii are congruent. So OY is congruent to OZ, and that's because all radii are congruent. And that line that we drew in, OX, we could definitely say it's congruent to itself. OX is congruent to OX because of the reflexive property. So we're on our way now. We have two sides. Now, the other givens were that YO was perpendicular to YX. So this right here and that, they form a 90-degree angle. So that would be there. And ZO was perpendicular to ZX, which is that. So those two are forming a right angle with each other. So let's write that in for step 7, the fact that we have right angles. So angle XYO and angle XZO are right angles. And that is because of the definition of perpendicular. We have perpendicular lines, so they form right angles. Now step 8, here's where HL comes in. For HL, I'm going to write up here, all you need is the hypotenuse of each triangle to be congruent. You need one pair of legs to be congruent, and you need a pair of right angles. Let's write up here too, one pair of legs congruent. This is exactly what we have in our figure right now. So we can say that those triangles are congruent. Triangle XYO is congruent to triangle XZO. And I'm going to say, well, it's by HL, the HL postulate. Let's list the things in that order. The hypotenuse that we had congruent was OX. That was step 6. The pair of legs that we had congruent was OY and OZ, which was in step 5. And then the pair of right angles that we just said that we had was in step 7. So that's how HL came to be in this figure. Now that we have the triangles congruent, you can think back to what I was saying on the first page. Our proof statement is asking us to prove a pair of sides congruent. So a pair of sides congruent means that we will have to use CPCTC right at the very end. And so we are ready to go ahead and say that Yx is congruent to Zx, which they are because they are corresponding sides of those two triangles. And so because of that, and because we just said the triangles were congruent, we can say that it's by CPCTC. And that is all. Some teachers call the HL postulate, they call it RHL. And they stick the R in there just so students remember that they need to have right angles. And the nice thing about HL is that in step 7, where we said that those two angles are right angles, we don't have to have another step after that that says those angles are congruent. It's enough in our proof just to say that they're right angles. And then from there, we had our triangles congruent to each other. So it's kind of nice to know HL because it'll save you that step in a lot of problems. And also, there is no such theorem as side-side angle, SSA. So we wouldn't be able to prove this if those angles weren't right angles. So it just kind of all ties in together and makes the proof doable. And that's it.